Hello everyone. In this video, I'm going to discuss about the brute force technique and also how to solve problems based on brute force approach from design and analysis of algorithms. So what is brute force? Brute force is a straightforward approach to solving a problem by trying all possible solutions or checking all possible cases. In the context of algorithm design and analysis, brute force techniques are often used as a baseline or a starting point for more efficient algorithms. Brute force algorithms are often easy to understand and also very easy to implement. This algorithm works well for all smaller sets of inputs. So some of the example which follows brute force approach are: number 1, computing a power n, where a is greater than 0 and n is a non-negative integer, meaning that a is multiplied by n number of times. Number 2, computing n factorial. Number 3, multiplication of two matrices. Number 4, searching for a given element in an array. As brute force is a straightforward approach, searching is done by using linear search. Sorting problems such as selection sort and bubble sort follows brute force approach. Now, let's discuss about selection sort, which follows brute force approach. Selection sort follows a brute force technique, that is, a straightforward approach for sorting the set of elements which is stored in an array in ascending order. So what is selection sort? Selection sort is started by scanning the array to find its smallest element and swap it with the first element. Then, starting with the second element, scan the elements to the right of it to find the smallest among them and swap it with the second elements. Generally, on pass I, where I ranging from 0 to n minus 2, find the smallest element in an array where array ranges from I to n minus 1 and swap it with array of I. Now let's discuss selection sort with a simple example. There are 4 elements given in our example, namely 7, 3, 2, 5, which is stored in an array. So to start with the selection sort, the first element in an array, which is 7, is assumed to be the minimum element. Now compare this assumed minimum element with all other elements in an unsorted array. So from our example, the minimum element in the array is 2. Hence, swap the element 2 with the first element, which is 7. Now, after the first pass, the output is going to be 2, 3, 7, 5. Here, the elements in the sorted array are 2 and the elements in the unsorted array are 3, 7 and 5. So after pass 1, consider the second element 3 to be the next minimum element in an array and compare this element 3 with the remaining element from an unsorted array. Since the element 3 is minimum among the remaining elements from an unsorted array, hence here swapping is not required. Now, after pass 2, the output is going to be 2, 3, 7, 5. Here, the elements in the sorted array are 2 and 3 and the elements in an unsorted array are 7 and 5. So after pass 2, consider the third element, which is element 7 as minimum element and compare it with the remaining elements from the unsorted array. Since element 5 is less than the assumed minimum element 7, swap the elements 7 and 5 in an array. So my output after pass 3 is going to be 2, 3, 5, 7, which is a sorted array in an ascending order. This is how the algorithm works. Now let's look into the algorithm of selection sort. In this algorithm, the array will be given and the elements will be placed from the position 0 to n minus 1. So the problem is sort the given array using selection sort algorithm. The input is an array of 0 to n minus 1 of orderable elements and the output is going to be again an array of 0 to n minus 1 of sorted elements in ascending order. Here, the outer for loop will verify the number of pass. At the end of each pass, one smallest element will occupy its position. After n minus 1 pass, the algorithm stops and the array gets sorted. The inner for loop is used to compare two elements, that is, the jth position element and the minimum element. So for every comparison, the inner for loop will get incremented. Likewise, the algorithm proceeds and once it finds the smallest element in an array, it swaps the minimum element with the first element in an array. And the procedure continues till all the elements in an array is sorted. Hence, after n minus 1 passes, the elements will be in a sorted manner. This is how the selection sort algorithm works, which follows a brute force approach. The next interesting topic is exhaustive search. Exhaustive search is a brute force approach to solve combinatorial problems. It suggests generating each and every of the problem domain, selecting those of them that satisfy all the constraints and then finding a desired element. The method of exhaustive search is number 1, to generate a list of all potential solutions to the problem in a systematic manner. Number 2, to evaluate potential solutions one by one, disqualifying infeasible ones, and for an optimization problem, keeping track of the best one found so far. Finally, when the search ends, it announces the solutions as found. So some of the problems which can be solved using exhaustive search are number 1, traveling salesman problem, number 2, knapsack problem, number 3, assignment problem. Now let's discuss about traveling salesman problem. In this problem, n cities with known distances between each pair is given. The task is to find the shortest tour that passes through all the city exactly once before returning to the starting city. Here, the graph vertices represents cities and the edge weight represents distances. The problem is to find the shortest Hamiltonian circuit for a given graph. So what is this Hamiltonian circuit? It is a cycle that passes through all the vertices of the graph exactly once. Now look into the given example. Since traveling salesman problem follows a brute force approach, the number of possible ways to solve the given problem is n minus 1 factorial ways, where n represents the number of cities. So in our example, we have 4 cities and n value is 4. Therefore, number of possible ways 4 minus 1 factorial, that is 3 factorial ways, which is nothing but there are 6 possible ways for solving a problem. You can proceed the problem starting with any vertices as the starting city to form a Hamiltonian circuit. So I am considering A as the starting city. Therefore, there are 6 Hamiltonian circuits formed. They are number 1, A to B, B to C, C to D, and D to A. The total cost is 17. The second possibility is A to B, B to D, D to C, and C to A. The total cost is 21. The third possible way is A to C, C to B, B to D, and D to A. So the total cost here is 20. The fourth possible way is A to C, C to D, D to B, and B to A. So the total cost here is 21. The fifth possible way is A to D, D to B, B to C, and C to A. Here the total cost is 20. Finally, the last possible way is A to D, D to C, C to B, and B to A. So the total cost is 17. So when I take A as a starting city, I am getting 3 possible ways. So among these 6 possible ways, the tour which has the lowest cost is considered as the optimal solution for this problem. Hence, the optimal solution is two solutions having lowest cost, that is 17. One is A to B, B to C, C to D, and D to A. And the other one is A to D, D to C, C to B, and B to A. So these two solutions are considered as the optimal solutions. Next, we will discuss about the knapsack problem. What is a knapsack problem? Given n items of known weights W1, W2, so on cases Wn, and the values V1, V2, so on cases Vn, and a knapsack of capacity W. The problem is to find the most valuable subset of the items that fit into the knapsack in such a way that the total weight of the items does not exceed the knapsack capacity W. So consider the problem given below. There are 4 items with weight and values given, and also the total knapsack capacity is W equal to 10. So the number of possible ways to solve the problem is 2 power n ways, where n represents the number of items. Here n is 4, and therefore 2 power 4 has 16 possible subsets possible to find the required solutions. Initially, I am considering the knapsack to be empty. Next, I am trying to place the first item whose weight is 7, which is less than the total knapsack capacity 10, and the corresponding value of item number 1 is 42. Next, I am trying to insert item number 2 whose total weight is 3, which is again less than the total knapsack capacity 10, and the corresponding value of item number 2 is 12. Next, I am trying to place item number 3 alone in the knapsack whose weight is 4, which is again less than the total knapsack capacity 10, and the corresponding value of item number 3 is 40. Next, I am trying to place only item number 4 inside the knapsack whose total weight is 5, which is again less than the knapsack capacity 10, and the corresponding value of item number 4 is 25. Now I am trying with the next possible combinations to place item number 1 and 2 inside the knapsack whose total weight is 10, which is equal to the knapsack capacity 10 and the total value when placing item number 1 and 2 is 54. Next, I am trying to find out the next combination of item number 1 and 3 inside the knapsack, whose total weight is 11, which exceeds the total weight of the knapsack capacity, which is 10. So this combination is not considered as a feasible solution. Next, I am trying with item number 1 and 4, whose total weight is 12, which again exceeds the total weight of knapsack, which is 10. And again, this combination is not considered as a feasible solution. Next, I am trying to place item number 2 and 3, whose total weight is 7, which is less than the total knapsack capacity 10, and the corresponding value of item number 2 and 3 is 52. Next, I am trying to place item number 2 and 4, whose total weight is 8, which is again less than the total knapsack capacity, and the corresponding value of it is 37. The next possible way is to place item number 3 and 4, whose total weight is 9, which is again less than the knapsack capacity 10, hence their value is 65. Now I am trying to place 3 items inside the knapsack, that is item number 1, 2 and 3, which exceeds the weight of total knapsack capacity, that is 10, hence it is not considered as the feasible solution. Next I am trying with the other combination like item number 1, 2 and 4. Again I find that 15 is the total weight 15 is greater than the total knapsack capacity, which is not considered as the feasible solution. The next possible combination is 1, 3 and 4, whose total weight is 16. Again, this weight exceeds the knapsack capacity, which will not be considered as the feasible solution. Next possible combination is to place item number 2, 3 and 4, whose total weight is 12, which again exceeds the total knapsack capacity, and again this is not considered as the feasible solution. Next I am going to place all the 4 items inside the knapsack and find out the feasible solution. I am now trying to place item number 1, 2, 3 and 4, whose total weight is 19, which again exceeds the knapsack capacity, and here this possible combination is also not considered as the feasible solution. So among this item number 3 and 4 is selected for the knapsack, which has the highest profit of rupees 65, and hence this is considered as the feasible solution for the given problem. Coming to the next problem, which is nothing but the assignment problem. So what is assignment problem? There are n people who need to be assigned to n jobs, one person per job. The cost of assigning person I to job J is C of I, J. The task is to find an assignment that minimizes the total cost. So consider this example where there are 4 persons assigned with 4 different jobs. The task is to assign each person with exactly only one job in such a way that the total cost is getting minimized. So according to the brute force approach, the number of possible ways is n factorial way to find out the optimal solution. Hence, n defines the number of persons, that is n is equal to 4 according to our example, and hence there are 4 factorial ways, which is 24 possible ways to find out the possible solutions. These 24 possible ways can be divided into 4 iterations where each iteration has all possible combinations of assigning job to a person. Now let's start with the problem. In iteration 1, I am trying to fix job 1 to person 1 and trying with other combinations of job for the remaining persons. That is, look into the step number 1, assigning job 1 to person 1, job 2 to person 2, job 3 to person 3, and job 4 to the person 4, whose total cost is 18. In step 2 of iteration 1, assigning job 1 to person 1, job 2 to person 2, job 4 to person 3, job 3 to person 4, whose total cost is 30. Coming to step number 3 of iteration 1, assigning job 1 to person 1, job 3 to person 2, job 2 to person 3, job 4 to person 4, whose total cost is 24. Coming to step number 4, assigning job 1 to person 1, job 3 to person 2, job 4 to person 3, job 2 to person 4, whose total cost is 26. Coming to step number 5 of iteration number 1, assigning job 1 to person 1, job 4 to person 2, job 2 to person 3, and job 3 to person 4, whose total cost is 33. Coming to the final step of iteration number 1, assigning job 1 to person 1, job 4 to person 2, job 3 to person 3, and job 2 to person 4. So among these 6 possible ways from iteration number 1, the minimum cost here is 18. Coming to iteration number 2, I am fixing job 2 to person 1 and trying with other possible combinations of job for the remaining persons. So in iteration number 2, step 1, assigning job 2 to person 1, job 1 to person 2, job 3 to person 3, job 4 to person 4, whose total cost is 13. In step number 2 of iteration 2, assigning job 2 to person 1, job 1 to person 2, job 4 to person 3, and job 3 to person 4, whose total cost is 25. Step number 3 of iteration number 2 is assigning job 2 to person 1, job 3 to person 2, job 1 to person 3, and job 4 to person 4, whose total cost is 14. Coming to step number 4 of iteration number 2, assigning job 2 to person 1, job 3 to person 2, job 4 to person 3, and job 1 to person 4. Coming to the next step of iteration number 2, that is step number 5, is assigning job 2 to person 1, job 4 to person 2, job 1 to person 3, and job 3 to person 4, whose total cost is 23. Coming to the final step of iteration number 2 is assigning job 2 to person number 1, job 4 to person number 2, job 3 to person number 3, and job 1 to person number 4, whose total cost is 17. So among these 6 possible ways of iteration number 2, the minimum cost found here is 13. Coming to iteration number 3. In iteration number 3, I am trying to fix job 3 to person 1 and trying with other combinations of job for the remaining persons. So here goes the steps. So step 1 of iteration 3 is assigning job 3 to person 1, job 1 to person 2, job 2 to person 3, and job 4 to person 4, and the total cost is 25. Step number 2 of iteration number 3 is job 3 to person 1, job 1 to person 2, job 4 to person 3, and job 2 to person 4. Coming to step 3 of iteration number 3 is assigning job 3 to person 1, job 2 to person 2, job 1 to person 3 and job 4 to person 4. The fourth step of iteration number 3 is assigning job 3 to person 1, job 2 to person 2, job 4 to person 3 and job 1 to person 4 whose total cost is 26. The fifth step in iteration number 3 is assigning job 3 to person 1, job 4 to person 2, job 1 to person 3 and job 2 to person 4 whose total cost is 25. Coming to the final step of iteration number 3 is assigning job 3 to person 1, job 4 to person 2, job 2 to person 3 and job 1 to person 4 whose total cost is 29. So among the 6 possible ways in iteration number 3, the minimum cost here is 20. Coming to iteration number 4, in iteration number 4, I am fixing job 4 to person 1 and trying with other combinations of the job for the remaining persons. That is, in step 1 of iteration 4, I am fixing job 4 to person 1, job 1 to person 2, job 2 to person 3 and job 3 to person 4 whose total cost is 31. Step 2 of iteration number 4 assumes that job 4 is assigned to person 1, job 1 is assigned to person 2, job 3 to person 3 and job 2 to person 4 whose total cost is 21. Step number 3 of iteration 4 assigns job 4 to person 1, job 2 to person 2, job 1 to person 3 and job 3 to person 4 whose total cost is 26. Step number 4 of iteration 4 deals with assigning job 4 to person 1, job 2 to person 2, job 3 to person 3 and job 1 to person 4 whose total cost is 20. Step number 5 assigns job 4 to person 1, job 3 to person 2, job 1 to person 3, job 2 to person 4 and the final step of iteration number 4 assigns job 4 to person 1, job 3 to person 2, job 2 to person 3 and job 1 to person 4 with a total cost of 26. So among the 6 steps from iteration number 4, the minimum cost here is again 20. So now considering these 4 iterations, the minimum cost found is 13. That is, when we try to assign person 1 with the job 2 and person 2 with the job 1 and person 3 with the job 3, finally person 4 with the job 4, the minimum cost found is 13, which is considered as the optimal solution to the assignment problem using brute force approach. Thank you.